All right, so today we're going to pick up where we left off and talk about the cross products or the vector product of two vectors. So another way of multiplying two vectors together is to use what we call the cross product. Again, IB calls this the vector product. It's the exact same thing. And this is going to give me a formula that I think is in your info booklet, and it's going to look a little complicated at first, but once we go through it, it should look very familiar to you. So they've got A is the vector in terms of ijk, and B is the vector in terms of ijk. Notation for it, A cross B indicates we're doing a cross product. Now, this formula, like I said, I think is in your info booklet. I'm not going to go through it because I think there's an easier way to see this, and that's to just look at this determinant. So A cross B can be thought of as the determinant of the vector that contains, or the matrix rather, that contains ijk in the first row, and then A1, A2, A3, and B1, B2, and B3 in the second row. And so the good news is this is the determinant, same determinant we were using back in the last chapter when we were talking about matrices. So we just put plus minus plus across the top, and then we expand row 1. So take a look at this and make sure you see where all of the elements are coming from. And again, I think this is in your info booklet or your reference sheet, but this is really just the determinant, so it's not a big formula to memorize. We'll do a couple examples here, but I think you'll have this down pretty quickly. So what does the cross product look like geometrically, and why is it significant? Well, A cross B is a vector, not a scalar like the dot product was. That's something you need to keep straight in your mind. So A cross B is the vector that is perpendicular to A and B. So look at this picture and see what's going on. We have vector A and vector B are in the same plane. So when we take their cross product, we get another vector that is perpendicular to that plane. So keep that in mind because you're going to see questions where they say, find a vector that's perpendicular to vectors A and B, and that's an indication that you're going to want to use the cross product. So here we go. So find all vectors that are perpendicular to both vector A and vector B. We're going to start off by doing the cross product. We're going to put it into our determinant. So ijk goes across the top. Then we're just going to expand this using the determinant formula. Remember, I is positive. That leaves us with 2, -1, 0, and -3. The j would be made negative, so that leaves us with 1, -1, 1, -3. And the k would be positive, so that leaves us with 1, 2, 1, and 0. When we calculate each little mini determinant, go ahead and calculate those, make sure you got them. You should wind up with -6i plus 2j plus 2k. So what I did here, and this isn't a totally necessary step, but it's probably what they did in the book, so I just went ahead and did the same thing. Factored out the -2 here, factored out a GCF. So the question said find all vectors perpendicular to both of these. So if you remember in the homework we were doing yesterday, they asked us to find a vector that was parallel, or all vectors that were parallel to something. We just put a multiple of c or k or whatever variable you want to use in front of that vector. I think you could have left the -2 in there. That still would have been an equivalent answer. But any vector that's a multiple of this 3i minus j plus k would be perpendicular to the original two vectors. Okay, so another example here. Find a direction vector of a normal to the plane passing through these 3 points. So normal might be a term that you heard of in physics class, but it's also a term we did last year when we were talking about a normal to a tangent line. Remember, was the line that was perpendicular to the tangent line. So in this case, when they say a normal, they're just looking for a vector that is perpendicular to the vectors containing those 3 points. Now, any combination of the vectors would work. You could use BA and BC, or CA and CB. I just chose AB and AC for simplicity's sake. We're going to find vectors AB and AC. Here's AB and AC. So a normal would be the cross product of these two vectors. We're going to set up our determinant. And then we're going to find the cross product. So if you work those numbers out, calculate those little determinants, and you should get negative 4i plus 14j plus 10k. By the way, any multiple of this would still be perpendicular to that plane. This is probably just the easiest one to stick with. A few properties of the cross product that you should be familiar with. If A cross B is a vector that's orthogonal, that's another word you need to know. Orthogonal just means perpendicular. Orthogonal to both A and B. And if you think about the picture, this is vector A and this is vector B. That normal is orthogonal to any vector, really, that's in this plane, that's orthogonal to both A and B. A cross A is equal to 0. But if you cross a vector with itself, it's 0. A cross B is equal to the negative of B cross A. So they have the same length, but they would go in opposite directions. Physics people, I think this is probably something you guys would use from time to time, so that should look familiar. And then the last part, that this is associative, A cross the sum of B plus C would be the same as A cross B plus A cross C. And that's it for cross product.